All right, this video is going to go over pages 12 and 13 in your packet. So we're going to start off with what is the frequency of a merry-go-round if it makes one revolution every 30 seconds. So what I just gave you there is I told you the time it takes for one rotation or one revolution. That is your big T. That is your period. Okay, the time it takes to go around one time. Okay, so A says what is the period of the merry-go-round? I'm sorry, instead of one, it says, what is the frequency? I forgot that part. What is the frequency? So remember, we know T equals 1 over F. Okay, so therefore, I know my period is 30 equals 1 over F. So remember, you can swap these back and forth. Okay, so 1 divided by 30, and that's going to give you 0.033 hertz. A, what is the period of the merry-go-round? Well, now we know that. Okay, so the key is not that you're solving for it, it's being able to make sure you know what you read in the problem. You've got to understand if I tell you that one revolution every 30 seconds, that is your period. That's the time it takes for one rotation, so your answer would just be 30 seconds. B, if a horse on the merry-go-round is 5 meters away from the center of the merry-go-round, so that means there's your radius, what is the linear speed? Okay, so remember speed is velocity, so velocity equals 2 pi r over t. So 2 pi times your radius, which is 5, over t, which we know is 30. So 2 pi times 5, okay, then divide that by 30, and you should get 1.05 meters per second. C, what is the centripetal acceleration of the horse? So remember we know AC equals v squared over r. So we're going to take that velocity 1.05 and we're going to square it, divide it by our radius of 5, and you should get 0.22 meters per second squared. D, what is the centripetal force acting on the horse if it has a mass of 100 kilograms? So remember FC equals mass times AC. So our mass is 100. Our acceleration is 0.22, and we're going to multiply that, and we get a force of 22 newtons. So if you notice here, B, C, and D, okay, those are your three main equations, so you got to make sure you can go back and forth between the two or use one to find what you're missing in the equation that you want. 2, Marianne puts her favorite Dave Matthews band CD in her CD player if it spins with a frequency of 1,800 revolutions per minute. So that's 1,800 RPM. What is the period of the spin on the compact disc? Okay, so remember T equals 60 divided by RPM. So 60 divided by 1,800, and that's going to give you 0.033 seconds. Okay, so there's lots of ways to find periods, so you just got to make sure, know what you're given, okay, because you could do multiple things. Like up here I could say T equals 1 over F, or time could be your seconds divided by revolutions. Okay, or you could do 2 pi r over v, or you could do 60 over RPMs. All of those are ways to find T. It just depends on what you have. If you don't have frequency, so let's say I was going through a problem. If I don't have frequency, then I cannot use this. If I don't have seconds and revolutions, I can't use this. If I don't have radius or velocity, I can't use this. But let's say like this, I have RPMs, then I can use that. Okay, so these are just different ways to find T. So you just got to use whichever one that you can use, which one based on the question you have. Okay, so going back down here, Hamlet, a hamster runs on his exercise wheel, which turns around once every 0.5 seconds. So that just gave you your period right there. There's your big T. What is the frequency of the wheel? So remember, frequency equals 1 over T. So 1 divided by 0.5, and that gives you a frequency of 2 hertz. So remember, frequency is the number of rotations in 1 second. And if Hamlet can spin around once every 0.5 seconds, that means he can spin around twice every second. So that's basically what that meant. Number 4, a sock stuck in the inside of a clothes dryer spins around once every 2 seconds. So there's your T. At a distance of 0.5 meters from the center, there's your R. What is the sock's linear speed? So V equals 2 pi R, which is 0.5, over your T, which is 2. You should get a velocity of 1.57 meters per second. B, if the radius of the clothes dryer were twice as big, but it continued to turn at the same frequency, would the linear speed be faster, slower, or the same speed as your answer to A? Okay, if you made that radius bigger, okay, twice as big, okay, so now instead of 0.5, it's 1. You can go ahead and put it in if you want to. You can see the calculation, how it changes it. So we're going to do 2 pi times 1 instead of 0.5, still divided by 2. Okay, and you're going to get a value of 3.14 meters per second. And if you notice, the difference between here and here is it doubles. So if you increase the radius, you're going to increase the velocity, because if you're covering more and more ground in the exact same amount of time, your velocity has to be faster. Okay, so if radius goes up, velocity has to go up as well. Number 5, what is the radius of an automobile tire that turns with a frequency of 11 hertz? So there's your F, and has a linear speed of 20 meters per second. So there's your V. That means you're looking for R. So we're going to do V equals 2 pi R over T. So 20.0 equals 2 pi times radius over T, but we don't have T. We can find it though. T equals 1 over F, so 1 over 11, and you get a time of 0.091 seconds. Okay, so 0.091 seconds goes on bottom there. So we're going to multiply both sides by 0.091 and then divide both sides by 2 pi. Just be careful with your calculator. We've seen some mistakes on if you don't use a parentheses right here. It divides it by 2 and then multiplies by pi. So just be careful with your answer. So you should get a radius of 0.29 meters. Okay, Luigi twirls around pizza dough overhead with a frequency of 60 revolutions per minute, so 60 RPMs. Find the linear speed of a stray piece of pepperoni stuck on the dough 10 centimeters away from the center. Okay, so there's my radius right there, but I can't have it in centimeters. So 10 divided by 100 gives you 0.1 meters. Okay, so we're looking for linear speed, so we're looking for velocity. So 2 pi times my radius, which is 0.1, over T. Well, I don't know T. I do know 60 RPMs, though. So remember, T equals 60 divided by RPM, so 60 divided by 60, and that gives you a time of 1 second. So 1 goes on bottom. So this one shouldn't be too bad. So 2 pi times 0.1 is going to give you 0.63 meters per second. In what direction will the pepperoni move if it flies off while the pizza is spinning? Explain your answer. So again, this is what we're talking about as far as tangent goes. So say this is our pizza right here, and we have a pepperoni out here on the edge. And we'll just say our pizza is spinning this way. If the pepperoni were to fly off at that point, it's just going to keep going tangent to the circle. Whichever direction it was heading at that given point, that's the way it's going to continue to go. And then number 7, the Earth rotates around its axis approximately once every 24 hours. So there's your time. There's your big T, because it rotates once over that time. But it's in hours. We're going to have to fix that. And then your radius, Earth, is 6.38 times 10 to the 6th meters. Okay, so my radius, I'm good. It's in meters. My time, not so much. So we need to fix that. So we got 24 hours. We're going to multiply that by 60 minutes and then multiply that by 60 seconds. That means it takes 86,400 seconds for a day. Okay, if some catastrophe suddenly brought the Earth to a sudden halt, with what speed would the Earth's inhabitants who live at the equator go flying off the Earth's surface? Okay, doesn't sound dark at all. Okay, but if we want to find the velocity of someone at the equator, how fast are they actually going? Velocity is 2 pi times your radius, which is 6.38, times 10 to the 6th, all divided by your T, which is 86,400. And that gives you a velocity of 463.97 meters per second. So, even though you don't necessarily feel that, if the Earth were to stop, okay, that's how fast everything would keep going in that direction. B, compare the speed of the equator with the speed while standing near either the north or south poles. Okay, so you've got your Earth right here, okay, and it's spinning around like this. Okay, and let's just say at the north and south pole, if you're spinning like that, if you were to look at the Earth from the top down, we'll just say this is looking from the top down, you're looking at the North Pole right there. Okay, so out here on the equator, you'd have your most velocity because you actually have a radius. But if you're right here smack dab in the middle, that means your radius would be 0 meters. And if you don't have a radius, that means you're not covering any ground at all. So therefore, your velocity would be 0 at the North or South Pole. 8, Jessica is riding on a merry-go-round on an outer horse that is 8 meters from the center of the ride. Jessica's sister Julie is on the inner horse, 6 meters from the ride center. The merry-go-round makes a complete revolution every 40 seconds, so I gave you T, and I gave you 2 radiuses. So we're going to find the velocity for Jessica and Julie. So Jessica, velocity is 2 pi. Her radius is going to be 8 meters over her time, which is 40 seconds. And that's going to give a velocity of 1.26 meters per second. Now, Julie, we're going to do hers. Okay, velocity would be 2 pi. Her radius is 6 meters. And the time is 40 seconds. Okay, so we're going to get a velocity of 0.94 meters per second. So if we want to know who's going faster, that's definitely going to be Jessica. And the reason why is because if you look at their radius, if radius goes up, your velocity has to go up as well. What is the centripetal acceleration of each of the girls? Okay, so Jessica, we're going to do AC equals V squared over R, 1.26 squared over your radius, which is 8. And you're going to get a value of 0.020 meters per second squared. And then we're going to do AC for Julie, which is going to be 0.94 squared over your radius, which is going to be 6. And that's going to give you a value of 0.15 meters per second squared. And that'll end that one.